Yes. Yes, the last time we discussed about given this IP address and a subnet mask, how to find this CIDR. So when we have the subnet mask is 255.255.254, we know we will have 8, 8, and 7. That means 23 bits were allocated for the network bits. Therefore, we can directly write the answer, right? So we can say that the answer will be 172.16.2.1/23, which is number of bits allocated, right? So here is the answer. Right. Okay. So today we are going to talk about another topic, new topic. Now, these are ones called private IP addresses. Now, why we call it private? Because within our local area networks, when we want to assign IP addresses, right, there'll be a couple of ranges we are going to use. So let's start look at this. Let's write down private IP addresses. Right. So that is what we are going to discuss right now. What do you mean by private IP addresses? Right. So under this one, we can talk about, right, what these private IP addresses. So the point here we want to make is these IP addresses are used when we create local IP addresses, local area networks, right? So what do you mean by local area networks? Like at homes, when you can connect to the router, this is the set of IP addresses usually we will get, right? Right. So let's write down now. When we say private addresses, again, we can talk about the three classes. So the first class is we call class A, start with 10.0.0.0, right? So that's the class A addresses. So it goes from, class A goes from 10.0.0.0 to 10.255.255.255. Sorry. If I go for CIDR method, we can say 10.0.0.0/8 because we have 8 bits allocated for the network. So the number of IP addresses that you can have in a class A is huge. So you can see you can have 16 million addresses are possible. Similarly, if you take class B network, it starts from 172.16.00 to 172.31.255.255. So CIDR format would be 172.16.0.0/12, right? Which gives you about like 1 million addresses. And the third one is a class C, which is what you normally see in our networks. So this is class C, which ranges from 192.16.0.0 to 192.168.255.255. So for example, if I go to my, screen, let's take my command line. If I say IP config, which will give us IP addresses. So you can see in my machine. So in this particular machine, for example, the IP address allocated is 192.168.802. This is class C address. So generally, when we connect to the internet and when we create the network, this is the class we are getting. Okay. So let's take down this. Right. So let's have a small subtopic on assigning IP addresses. So nowadays, the IP addresses are assigned manually, automatically, and usually through what we call the DHCP server. So this term DHCP stands for Dynamic Host Configuration Protocol server. So simply what it does is it will assign IP addresses automatically. Let's say you have 4 computers, it automatically assigns. So in my machine also, right? This is how we will get the IP addresses, right? So we will get unique IP addresses for all the computers in our network, right? So the computer who's responsible for doing this is called DHCP server. Right. So the next topic we are going to talk about is called switching. Now the term switching is, right? So the term switching is we use to connecting, right, or transferring or sending data from one place to another place, right? So for that, we use the idea of switching. Now, what it means, right? So there are 2 ways we can have switching. The first one we call packet switching. The second one is the old one we call circuit switching, right? So let's write the 2 things. There are 2 types, and the 2 types are the packet switching and circuit switching. So this is called packet switching. So that means you send them as packets, right? The other one is like traditional circuit-based switching. So traditionally, this is the technique that we have used. So you have to have a choice between packet switching and circuit switching. Right. So I will give you time to take down, but let's first look at some videos. We want to talk about circuit switching, right? So the circuit switching means we are going to create some physical connectivity. Now packets are like I told you, whenever we have some message, we broken into pieces, and these different pieces can take different parts and then they can meet at the destination. So that's how the packet switching works. And the second one is what we call circuit switching. That means we are going to have physical, right, connectivity between the send and receiver. And this is the old-fashioned way people actually used early days, right? And to share you a picture on this, so it looks like this. So what you see here is, right, so we will have 2 sender and receiver, let's say. So these are called switching offices, like places where we have switches, and these switches are connected to each other. And then we will, let's say this telephone wants to connect to this telephone, then it will connect a physical connection between the switches from starting point to the end point. And this is what we call circuit switching. So we can say in circuit switching, we are going to create a dedicated, a link between 2 hosts. So we can say in circuit switching, we are going to create a dedicated link between 2 hosts. Okay, so let's take down this.